Hello everyone. Let us see the numerical which is given as a moving coil of a meter has 100 turns, a length and depth of 10 mm and 20 mm respectively. It is positioned in a uniform radial flux density of 200 millitesla. The coil carries a current of 50 milliamperes. The torque on the coil is, it is asked in GATE 2004, and here are the options. So what is given in this numerical? That is the moving coil. What do you mean by moving coil? That is nothing but the permanent magnet moving coil. For that, turns are given, that is the number of turns which is denoted by N, that is given as 100. Length and depth is given 10 mm and 20 mm. And flux density is given. Flux density is denoted by B, which is given as 200 millitesla. And it carries a current. Current is denoted by I, which is given as 50 milliamperes. And what is asked? That is the torque on the coil. So let us see what is the given data. N, number of turns, that is 100, length, depth, flux density, which is denoted as B, current, which is denoted by I. This is all the given and asked, that is the torque, which is denoted by T. So for finding the torque, what is the formula for the torque of PMMC instrument? That is given as torque is equals to NIAB. N, number of turns, I, current, A, area of the coil, B, flux density. So finding this torque, what is the unknown? The unknown, that is nothing but the area. So how we will find out the area? For finding out the area, what is given? The length and the depth is given. So for finding the area, what is the formula now? Area of the coil becomes length into depth. Now substitute the values of length and depth to find out the value of the area, which is coming out to be 0.0002 meter square. Now we know the number of turns, the current, the area and the flux density. Now substitute all the values in the torque equation. Now the torque equation becomes this one, that is the 100 into 50 into 10 to the power minus 3, that is the value of the current, 0.0002, that is the value of the area, and 200 into 10 to the power minus 3, that is the value of the flux density. After calculating all the values, what we will get? The torque as 0.0002 Newton meters. But in the option, you can see that the unit which is given, that is the micronewton meters. So here what we have to do? We have to convert this torque from Newton meter to the micronewton meter. So when we are converting it, what will become the value? That is 200 micronewton meter. Now see the options. What will be the correct option here? That is 200 micronewton meter, option number A. Option number A is the correct answer. So for finding the torque for the PMMC instrument, it is given as torque is equals to number of turns into the area of the coil into the current into the flux density. That is the formula for the torque to find out. And in this numerical, it is found out as 200 micronewton meters.